to learn about the adverse effect today. We will start with the adverse effects of sulfonamides. The main problem is crystalluria. Since the sulfonamides are excreted in urine, they are water insoluble. So when they get converted into a derivative of, that is the metabolite, the metabolism will be taking place by aromatic oxidation type and primary amino. There is a primary amino group involved. So the primary amino group will be involved in various metabolic reactions. So when that occurs, when one hydrogen is replaced with one acetyl, N-acetylation will take place. So if you see the metabolic reactions, the metabolism will be taking place by phase 1 mechanism and phase 2 mechanism. So phase 1, most of the times the cytochrome P450 enzyme will act on the drug and it will get converted into the metabolite. And then the phase 2 will be like the secondary pathway. So when the sulfonamide moiety gets metabolized, the primary amino group will get converted into acetylated form. So the acetylated form, N-acetylation will take place. So capital N is for the nitrogen, N-acetylation will be taking place. So the metabolite or the derivative of sulfonamide during its excretion after activity, it will get converted. So all the drugs, most of the drugs will be going for aromatic. If it contains an aromatic ring, then it will go for oxidation, hydroxylation. So aromatic hydroxylation is the common thing. When there are some specific groups, then N-acetylation, hydroxylation, all these things will be taking place. So once in this case, when the sulfonamides gets converted into the acetylated derivative, they are water insoluble, hence they will be deposited. So in the renal system they will be deposited, and so the formation of, so when they are when their pH is more and they form a crystal, the particular adverse effect is called as formation of crystal in the urine is called as crystalluria. So when you give sulfonamide, the main adverse effect is crystalluria, formation of crystals in the urine. So to avoid that, there are very simple techniques like conversion of the group into a prodrug, conversion of the active form into a prodrug, and like whenever you are giving sulfonamides, an adjuvant will be added in order to increase the excretion. Thereby, the crystalluria will be prevented. And also there are other tips to exclude this or to modify this crystalluria. So crystalluria is an adverse effect where there will be a formation of crystals in the urine. So one thing you have to remember here, all the drugs or most of the drugs gets after therapeutic activity, they have to get excreted from the body. For that, most of the drugs will pass through the first pass metabolism. The first pass metabolism will take place in the liver. So liver is a place where most of the drugs will go for their breaking down. So the enzymes present in the liver will act on the drug and they will transform into another form which can be easily excreted. So that way most of the drugs will get converted into another form which can be excreted by the excretory system. So this is the normal pathway. So once the drug has to get absorption, after that it has to get distributed, then it has to get converted into the metabolites, and the metabolites are easy for excretion. So ADME property means absorption of a drug, distribution to the particular site, and after therapeutic activity this has to get eliminated. So conversion of the active into the metabolite form and the metabolites will be excreted. So this property of the drug inside the body is called as dynamic, and it is absorption, distribution, metabolism and excretion. So we are more particular about the in the new drug discovery. We have many n number of chemicals which are biologically active outside the body. So they are outside the body, they are biologically active. Hence it's called as in vitro compounds. In vitro activity will be seen. In vitro or in vitro activity means outside the body there will be the effectiveness of a chemical or a drug will be more. But once it enters the body, it has to have this ADME properties: absorption, distribution, metabolism, and excretion. For that, we have lots of hurdles inside. So that's why the new drug filing or new drug discovery becomes a great challenge. So when you go for filing a new drug, it will take approximately at least minimum of one drug to come into the market. It will take 10 years minimum. So when you hear this COVID-19 and all, you would have heard about the vaccines, which are like we are modifying the law also due to emergency and all. So these things and all, as a family student, you have to know about always the dynamic and the kinetic properties. So pharmacodynamic and pharmacokinetic properties you would have studied in your formulation and all, so that you need to recollect. So the sulfonamides, the drug through N-acetylation pathway, it will get converted into the N-acetyl form of sulfonamide. This acetylated form is precipitated out. So they cannot get eliminated easily. So the formation of these crystals in the urine is called as crystalluria. So once they get deposited in the renal system, so that's called as crystalluria. So how to overcome this problem of crystalluria? So we have to push it out. So the crystals has to push it out through urine. So drinking of more amount of water, and also since the pH is less, we have to increase the pH. So the urine pH is increased by converting those salts into soluble forms. So they are converted into another form so that the pH will be increased and so they can be eliminated out. And also another way is we have to modify the sulfonamide group by adding certain groups. So that's why it's pro-drug form. So we have to modify this group with easily ionizable compounds. So these are the three ways. One is we have to add, drink more water, increase the urine content so that the crystals will be pushed out. And another way is we have to add while you are taking a sulfonamide formulation, you will be prescribed with an alkalinizer. So an alkalinizer will be added in the prescription so that that will be taking care of the, this will be added. So this will be taking care of the pH and it will increase the pH of urine. Thereby the drug or the crystalluria is affected. And uh, you can lower the pKa by modifying the groups present in the drugs. So lowering the pKa value also will help for ionization. So these are the ways. So the point to be remembered is what is meant by crystalluria and how to avoid crystalluria. So what are all the various ways? So these are the various forms of sulfonamides which will be, this is a modified form so that the pKa value, there is a variation in the pKa value, thereby we can do a little modification in the structure so that the crystalluria is avoided. So in case of sulfanilamide, the pKa value goes for 10.4. So we are trying to convert the form into more ionizable and solubilized form. So, so the pKa value will be matching with that of the, so when you have a non-ionizable form, that time it will not be eliminated fast. So the conversion can be done by modifying the groups. So the modification is done by adding hetero rings and by adding certain salt groups or conversion into salt. So these are the various ways how to prevent crystalluria. So crystalluria is the adverse effect seen with the sulfonamides. There are three ways, simple three ways: increasing the urine outflow. Second one, by enhancing the or by altering the pH value by adding alkalizing agents like sodium bicarbonate, potassium citrate. Number three, converting the drug into another form so that the adverse effect is not seen. So these